Antigen recognition in the absence of co-stimulation leads to T-cell tolerance. Antigen recognition in the absence of co-stimulation inactivates naive T-cells, inducing a state known as anergy. The most important change in anergic T-cells is their inability to produce interleukin-2 or IL-2. This prevents them from proliferating and differentiating into effector cells when they encounter antigen, even if the antigen is subsequently presented by antigen-presenting cells. This helps to ensure the tolerance of T-cells to self-tissue antigens. Although anergy has only been demonstrated formally in vitro, there is sufficiently compelling evidence from studies in vivo showing peripheral tolerance to various antigens to assume that it happens in this setting as well. Any protein synthesized by all cells will be presented by antigen-presenting cells in the thymus and will cause clonal deletion of the T cells reactive to these ubiquitous self-proteins. However, many proteins have specialized functions and are made only by the cells of certain tissues. Because MHC class I molecules present only peptides derived from proteins synthesized within the cell, such tissue-specific peptides will not be displayed on the MHC molecules of thymic cells, and T cells recognizing them are unlikely to be deleted in the thymus. An important factor in avoiding autoimmune responses to such tissue-specific proteins is the absence of co-stimulatory activity on tissue cells. Naive T cells recognizing self-peptides on tissue cells are not activated. Instead, they may be induced to enter a state of anergy. Although the deletion of potentially autoreactive T cells is readily understood as a simple way to maintain self-tolerance, the retention of anergic T cells specific for tissue antigens is less easy to understand. It would seem more economical and efficient to eliminate such cells. Indeed, binding of the T cell receptor on the peripheral T cells in the absence of co-stimulators can lead to programmed cell death as well as to anergy. Nevertheless, some T cells persist in an anergic state in vivo. One possible explanation for this is that such anergic T cells have a role in preventing responses by naive, non-anergic T cells to foreign antigens that mimic self-peptide, self-MHC complexes. The persisting anergic T cells could recognize and bind to such peptide MHC complexes on antigen-presenting cells without responding, and thus could compete with naive, potentially autoreactive cells of the same specificity. In this way, anergic T cells could serve to prevent the accidental activation of autoreactive T cells by infectious agents, thus actively contributing to tolerance. And that's antigen recognition in the absence of co-stimulation leads to T cell tolerance.